Okay, so we're going to talk a bit more about equations today and slowly uh, dive into getting our calculator going. Okay, I don't know if we're going to get there today, but we'll see how far we get. Okay, so the main goal of us rewriting is this. Okay, you might wonder, why are we rewriting? That's okay. Why are we rewriting? The short answer to that is that I'm going to clear all of my entries here, but when you're trying to graph, right, you can only enter an equation that you want to graph that is written as y is equal to something else, right? So that's our main reason why we're rewriting, because we cannot graph any other form. Okay, so that's the basic reason why I'm doing this. And you should also be able to graph, right? So we'll do that now. And so I'll start with B here, this one. And that's 4x minus 2y is equal to 18, right? That's the question. And so we go negative 2y is equal to negative 4x plus 18. Remember, the 4x comes over, changes its sign. Then we divide everything by negative 2, both sides. Y is equal to 4. They're both negative, so it's going to give a positive 2x. Positive divided by negative is negative 9. Okay, so that should have been your equation. Your slope is 2, positive. B is negative 9, which is 0, negative 9. That's where you're going to start your graph, right? And I'm going to be a little bit faster today with my graph, okay? Because the idea is that you already did this. And I'm going all the way to negative 9, right? So I have to be careful with my scale. So if you wanted to do this, okay, I'm going to kind of always push the envelope a little bit here. So this is x-axis, y-axis. Don't forget your labeling. I'm going to go negative 5, negative 10. Okay, and then I'm also going to do the same thing here, 5, 10, because you're going to have to realize that it's not always going to be exact, and that is fine as long as it is within reason. Okay, so it has to be reasonable. So if you are at negative 9, you're somewhere here. Okay, that's where you start, and then you go 2, 1. So 2, 1 would put you right about here. And if you kept going, right, 2, 1 would put you right about there. As long as they line up, and this is true for grade 12 applied as well. Oh, there's another student that is lost. I'm just going to go help them quick, okay? Mr. Stacy, yeah, the very first one. Okay. Sorry about that. Anyways, there's your line, and y is equal to 2x minus 9. So if you want to have it like exactly where it's supposed to be, the truth is, as long as it's approximately, is fine. Okay, you don't have to have it right on, because we're going to deal with hundreds, thousands, 10,000s. You can't have a grid, right, that goes up by 1. It's impossible. So this is still a positive slope. It has arrowheads. It's labeled. You tell me where it starts, right? So it's good enough. Okay, next, C. C would have been 6x minus 5y minus 25 is equal to 0. And here, it's just that everything is on the left side. So we want to bring everything other than y over. So negative 5y is equal to negative 6x, right? And this comes over positive, like that. Then you divide everything by negative 5. Y is equal to, this is going to be positive because the 5 affects this and it affects that, okay? So it would be 6 over 5x like this, positive, minus 5, because it's 25 divided by negative 5. So your slope is 6 over 5, and your intercept is negative 5, right? Which is 0, negative 5. There. Okay? And so to have a grid here, I know my line is going up like this. And I'm going to start at negative 5, okay? So this one, this is also okay, by the way, like to just have, for example, to focus more on this end here. That is fine. It's almost like you're zooming in. As long as you're consistent, right, you'll be fine. This is X, this is Y. And if you need, this is another thing I tell my students, there's nothing wrong with erasing and extending or making changes, okay? Sometimes like, oh, I'm stuck, right? This is it. No, you don't. There's a lot of ways to fix things, okay? So if I go 1, 2, 3, 4, 5, that actually works out, right? So I'm going to go like that. I'm going to label maybe every second one like that. I'm going to go 1, 2, 3, 4, 5 like that. So I'm going to go 2, 4, right? So you're starting at negative 5 and you're using a rise of 6 and a run of 5. Okay, so you're going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, like that. Very far apart, but that's all you need really if you want to make a line, okay? There's the arrowheads. You can label it using this one if you'd like. Right? You don't have to use the rewritten form. You can use either one because they're both representing the same line. Okay. D, 3x plus 2y is equal to 12. 2y is equal to negative 3x plus 12. Divide everything by 2. Y is equal to negative 3 over 2x, right? Because it's negative and a positive. And it also affects the 12. 12 divided by 2 is 6. And so my slope is negative 3 over 2. And 6, which is 0, 6. It's my starting point, right? All right, so I'm going to do a graph. So you kind of have to already try to envision this. You're starting 0, 6. So almost imagine an x and a y axis. You're going to start up here, and it's going to go 3, 2, 3, 2, 3, 2, right? Negative. So it's okay to focus a bit more on the right-hand side of this graph. I'm going to start at 0, 6. I'm going to give myself some room there. Right? 3, 6, maybe one more. So I'm showing you different tricks to make things easier, okay? And so I'm going to go make my markings, okay? They're equally spaced out. 2, 4, 5. That's good to just have a 5 there as well. So it'd be 5 and then 10 way up here and so forth. We'll just continue that. And we're going to go 1, 2, 3, 4, 5, just go up 5 there. And then you know, right, just by looking at this number, okay, you're using a scale of 1. You're using a scale of 1. You're consistent. Okay, so I'm going to go 0, 6, which is up here. And I'm going to use my slope. And remember, I always associate the negative with the top number. So if it's a negative, then you're dropping. If it's a positive, you're rising, but you're always running to the right. Okay, so it's 1, 2, 3, 1, 2. And if you want to do one more, 1, 2, 3, 1, 2. There it is. So you just make it work, right? So see what happened there? So you just make it touch the line like that. There we go. That works anyways. So it's 3x plus 2y is equal to 12 would be represented by that line. Good? I feel like I'm not gonna do all of them. I'm gonna skip E. I'm gonna rewrite E but not graph it. How's that? E is 4x plus 7y is equal to negative 7. Like that. So the 4x comes over. Equals to, oh, no. My bad. We want the y on the left side, right? So it's 7y is equal to negative 4x minus 7. Divide everything by 7. Y is equal to negative 4 over 7x minus 1. Maybe I will graph this just because the slope makes it difficult, right, if you're not careful. So you got to imagine you're starting at negative 1 and then it's going to go down 4 over 7, right? So you kind of have to say, well, I'm going to focus on that, okay? It's almost like you're zooming in to a certain part of the Cartesian plane. Okay, so x and y like that. And I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, because I know I'm going to need some space this way because your run is 7, right? So then you're going to go 1, 2, 3, 4, 5. Sorry, this is supposed to be right there. This is negative 5. 1, 2, 3, 4. That's it. Patch it up there. And so you're starting at negative 1. And then you're going 1, 2, 3, 4. And I'm just looking at the top there until I get to about 7. And I'm just going to go up and match it up like this. There. So that's where it should be. Okay. And we know we expect our line to go down from left to right because we have a negative slope. Okay. And don't feel free to extend your line past. There you go. So it's okay to do this, okay? It's okay to focus more on where the line is going to be seen, okay? F and G, I might do those on the same grid. So F is 2x is equal to x plus 5. There are no y's there, okay? Y is not present, okay? Therefore, this is going to be a vertical line because you have x is equal to a number, right? Like you're ultimately going to have x is equal to a number. So 2x is here, x is there. So I'm going to bring that x over, subtracting, and I'm left with 5 on the other side. And so that ends up being x is equal to 5. Slope is undefined, okay? I'm going to graph that on the same grid, so I'm going to just jump to G. And there we have 1/2 y minus 2 is equal to -5. Again, x is not present, therefore horizontal line. Because, right, you're going to have y is equal to a number. So 1/2 y is equal to -5 plus 2. So 1/2 y is equal to -3. You multiply both sides by 2. Right, this cancels out here. So y is equal to -6. And so x is equal to 5, y is -6. So if I just do like a 5 by 5 or something like that, that should do it. So I'm going to use a scale of 1, I think. 1, 2, 3, 4, 5, 6. I'm going to label every second one. Just continue a little bit to the left. And then this is -6. So I'm going to go 1, 2, 3, 4, 5. And I'm kind of running out of, I ran out of space. So you have two options: adjust your scale or extend the line. It's up to you. So if you want to make this 2, 4, 6, right, then that works. If you want to extend your line, that for some of you that might be easier. So it's -2, -4, -6, like that. You can choose to do so. So let's do the horizontal line. It's going to go right through -6, like that. For some reason, students mix them up all the time. So I don't know if you need to have this. I need to emphasize maybe this being on your study sheet. Right, that's the line y equals -6. And the line x is equal to 5. 5 is right here. Basically, another way of thinking about it is no matter what y is, x is always equal to 5. Right? What is y? I don't know, but it's x is 5, right? X is 5, x is 5. So it's always x is 5. What would this point be right here? The coordinates of that point? That would be 5, right? X is 5 and y is -6. That's just an added bonus there. So freebie. But it comes back later. Okay, so that's the homework check, or making sure you're all on the right page there. And we're going to continue with our notes. Yeah, okay. Graphing. equations using the intercepts. Graphing equations using the intercepts. So we're going to change it up slightly. Firstly, to find the x-intercept, comma, let y equal to 0, right? And then what you're going to get is a point where of an x, a number for x, but y is going to be equal to 0. So in general, that's what it always looks like, an x-intercept. To find the y-intercept, let x equal to 0. And so what you get from that is x is equal to 0, and you're going to get a value for y. For the following equations, I find the intercepts, double I rewrite into slope intercept, and I mean rewriting it to this form. Triple I graph the equation. EQN, if you ever see that, that's equation. Okay. SOLN, if I do that, that's the solution. Okay. Let's see if I can zoom in just a little bit more here. Okay. Let's do the first one together. 3x minus 2y is equal to 3. So I do a little bit of a T-chart like this. I'm going to find the x-intercept here. And for now, I'm just going to let you know, right? That's when y is equal to 0. And next to it, I'm going to find the y-intercept. And that's when x is equal to 0, okay? So we have them both side by side, easy to see, easy to get. So to find the x-intercept, I need y equal to 0. So let's go 3x minus 2 times 0 is equal to 3. That leaves me with 3x is equal to 3 because the 2 times 0 just goes to 0. Divide both sides by 3. X is equal to 1. So 1, 0 is the x-intercept of this line. Now the y-intercept. I let x equal to 0, so 3 times 0 minus 2y is equal to 3. That leaves me with negative 2y, because this turns into 0, is equal to 3. Divide both sides by negative 2. And that leaves me with y is equal to negative 3 over 2. And you could say 0, negative 1.5. So in IPR, you would not have wanted to turn that into a decimal. In applied, that is fine to do. And then what I normally do is I box this in so that, the x and y intercept are easy to find. They're right there. So this would be I, right? Double I is asking me to rewrite. So that would be, I'm just going straight from this, okay? I'm jumping from the original to here. And so I will automatically bring the 3x, right? The 3x, I will bring that over, and that'll be reflected here. Plus 3, because the 3 is already on that side, and it's positive, right? Then I divide both sides by negative 2. Y is equal to negative and a negative, that'd be positive. And then 3 divided by negative 2 is just negative, right? So that's rewritten like that. And then triple I, we're going to graph. And I like the intercept method more because it kind of tells you what scale to use. Okay, if you just look at it, you're like, okay, 1, 0, I can kind of picture where that is, and 0, negative 1. And then I'm going to connect those two dots, and I'm going to have my line. And it doesn't need to be a big coordinate plane, right? Like I just need to make sure I get those intercepts in. Yeah, you're going to be really good at graphing by the end of this course. 1, 2, 3, 4, that's it. I'm going to use the same everywhere. I'm going to use the lines when it comes to y, right? So this is negative 2, positive 2, negative 2. Oh, sorry, positive 2, negative 2. It's good enough. You're going 2 in each direction, just labeling it once, just to let me know that's the scale. I'm using a scale of 1 here, and I'm using a scale of 1 here, even though, right, the 1 here is bigger than a 1 unit along the x-axis, and that is okay. Then we have 1, 0, which is right here. 0, negative 1.5. That would put me between negative 1 and negative 2 right there. So these are my 2 points. And then I just connect them and graph. And this is the line 3x minus 2y is equal to 3. Mr. Erickson, could I have used this one here? This rewritten one, start with the intercept, right? And then use 3, 2, 3, 2. Yes. It is usually a little bit more difficult, especially if you're starting in halfway, right? It would be 1, 2, 3, and then 1, 2. So you would land right there. That is also a way to do it, but I would recommend if you're doing the intercepts, use those to graph your line. Okay. And now I'm going to get you to try. You know what? Just for this one example, I'm going to make sure you understand that we used the intercepts, right? That, right? We use the intercepts to graph that. So I don't need you to label that because you already have done your scaling and you've told me here what they are. I don't need them to appear again here. Okay. Okay, so here are the ones I want you to try. Um, to make things less messy right now, just do uh, just do the finding the intercepts and rewriting. Don't graph for now, okay? So just do I and double I, okay? That way, graphing will take a little longer. So I just need you to be able to do the intercepts. So I will give you some time to do that right now, and I will give you the answers in a bit. Okay, so we still have half an hour, so I'd say let's try 15 minutes or so for now, see how it goes, and then we'll reconvene. Okay, so just work on that for now. So I'm gonna basically just get the intercepts and the we'll also deal with the more complicated ones here, and we'll rewrite it as well. Okay, so it's important to know that uh, slightly different approaches do not necessarily mean that it's wrong the way you're doing that. It might just be different compared to what I'm doing. Okay, so if you have something like this, if you find the x-intercept and the y-intercept right next to each other, okay, you automatically if for x-intercepts y is equal to 0, right? So you can actually bypass that step where I show you where you plug in the 0. You just go like this because the y is gone, right? And then you divide both by -2. So it's actually not that bad. Okay, so you go negative 0.50 there for the first one. The y-intercept x is equal to 0, so all of this will be gone. So you really just left to y is equal to 1, so it's 0, 1. Okay, so that's I basically. And so double I, right? We just move the 2x over, comes over adding, and you're done. Okay, for C, 3x minus 2y is equal to 9. That would be if you have your x-intercept here. It's just to be organized because later on you might have more than one of these. So to have it all in one place. Okay, so we let y equal to 0, so it's really 3x is equal to 9. So you divide both sides by 3, x is equal to 3, and it's 3, 0. Okay. Over here, you let x equal to 0, meaning this whole thing will disappear. Don't forget the sign. Okay. Like that. And so y is equal to negative 4.5, really, right? 0, -4. And remember, you're going to be able to use a calculator for everything, okay? Every time. Even when it says mental math sometimes on the paper. Because you still have to, a calculator alone will not save you, okay? Rewriting this, so it's 2y is equal to -3x plus 9. Divide both of them by -2. Y is equal to positive 3 over 2x minus 4.5. Especially if it's a finite decimal, it's just fine to have a decimal there. If it's repeating decimals, and I would prefer you keep it as a fraction when entering it into the calculator later on. Okay, that's for tomorrow. This is a bit more challenging here. Right? I would clean that up a little bit. So what I mean by that is, right, -3 times x and -3 times -3. So that'd be -3x plus 9. So if you've done it differently, don't erase anything yet. You might actually be surprised, right? I'm going to bring the two constants, I'm going to bring everything over to the C is, did I make a mistake on C? Let's see what the 3, oh, did I mix that up? Yes. I have two choices here. But you all went by this. Yeah, it's 3y. Yeah, okay. This is what I'm doing. I'm just gonna fix it. So I'll show you how you fix things. Okay. Thank you for pointing that out. And I actually did that on purpose when I gave you that, and I fell for it myself. Okay. So there you go. 3y minus 2x. So how does that change? X-intercept. This goes to 0. So basically, we're gonna flip-flop the answers, right? This goes to 0, so it's -2. And then you would have to divide both by -2. And that gives you -4.5. I apologize if I made you erase. I know that it will happen from time to time. I wish I could say it never happens, okay? So this is 0 here, so it's 3y is equal to 9. I'm just going to go ahead and erase. So divide both sides by 3, and this is y is equal to 3, so 0, 3, and that will change this as well. Okay, let's do this again. So this is 3y, 2x plus 9. Divide both by 3. You get 2/3 x plus 3. Is that better? I apologize for that. It's not Friday yet, is it? That normally happens on Fridays. Okay, so let's do the more complicated one. So shake this off, okay? Shake that off. Okay, it happened. Move on. We're gonna distribute this. We get that, and then we get -3x not plus 9 minus 4, right? The 4 I bring over because I want the numbers all on one side if possible. Y is equal to -3x plus 5. And you're like, this is already rewritten, Mr. Dirksen. It's like, yeah, kind of, this is already taken care of, right? So we're going to do I here, x-intercept, y-intercept. So if you did this first, that's fine. It's just a little bit more work perhaps. So I'm just going to go over here, and the x-intercept, you let y equal to 0, and that's negative 3x plus 5. You bring the 3x over, that's equal to 5. Divide both sides by 3. X is equal to 5 over 3. I'm just going to leave it at that, like that. Okay. Next, y-intercept is already easy, right? We know it's going to be 5. So it's 0, 5. So this is already double I here. So I kind of did that before I did the other one. Not a big deal. It's all connected. Okay. E. Oh, 5 minutes left. I better hurry. E. 0.2x plus 0.3y is equal to 0.5. How do you deal with that? The answer is multiply the whole equation by 10. That's what you do with decimals, like that. Just multiply everything, both sides of the equation, by 10, and that gets rid of the decimals. Okay. X-intercept, y-intercept, and you get 2x is equal to 5. Divide both by 2. X is equal to 2.5. 2.5. Right, this one ends. So I just used the 2.5. Y-intercept, 3y is equal to 5. Divide everything by 3. Y is equal to 5 over 3. That one I'm going to leave as is. Double I. I'm just going to go by the one where I multiplied. And so that's 3y is equal to negative 2x plus 5. Divide everything by 3. Y is equal to negative 2/3 x plus 5 over 3. Because I know that this is 2.333, right? Oh, sorry. 1 and 2/3, so 1.6 repeated, right? We don't want that. Our calculator is more accurate if you keep it as a fraction. Okay. F and G. What I'm going to do here before we go, I'm going to give you the answers to that. So for F, you get 12, 0, and you get 0, 6. See if you can get that going. And the rewritten form is this. Okay, that's for F. For G, it's negative 1, 0, and it's 0, negative 0.8. And the rewritten is this. So there, that's your homework to get that going. And on top of that, you got this booklet, okay? It looks like this. Don't worry about that first page. That's just a reference sheet that I added there. If you're home, it looks like this. I'm going to cover that up once. So go look for this booklet and then open it. And you should see the standard form to slope intercept form. I don't want you to do all of them. Just do all odd questions. And I will post the answer key to that. So all you have to do is rewrite it to slope intercept. And tomorrow we're going to use our calculators, okay? So have them ready. Bring your signed forms, okay? If you have them already. And so this is your homework. I'm going to uncover the answers there if you're still copying. Once you're done